Welcome to the deep dive. Today we're looking at those high-performance plastics in your RC cars. You know, the polycarbonate, Lexan, the ABS, the stuff that lets them survive, well, almost anything.
Right, stuff that makes them incredibly durable.
Exactly. But here's the twist, the paradox, really. That amazing durability, it creates a real headache, an environmental one, when the car reaches its end of life.
Yeah, that's a really key point. We tend to ask if something's recyclable, but maybe not, how it fits into the bigger waste picture. So today we're going to frame this using the hierarchy of responsible disposal. Think of it less like which bin and more like a strategy. How do you get the most value out of that material before you even think about disposal? Our goal, to kind of demystify why these plastics don't work in your regular recycling bin and give you, the listener, a clear, actionable guide.
All right, let's dig into that durability curse then. So we've got polycarbonate Lexan, right? That's for the bodies, needs that high impact resistance. And then ABS, that's more for the rigid parts, like the chassis, gear housing, stuff like that.
Exactly. But there's a hidden cost to that toughness, chemically speaking. Polycarbonate. It's made using bisphenol A, BPA.
Oh, right, BPA.
Yeah, and if that PC ends up in a landfill, the BPA, which is an endocrine disruptor, it can leach out. Over a decade, sure, but it can happen.
Okay, and ABS?
ABS is kind of similar. If it starts breaking down, it can release its basic parts, acrylonitrile Butadiene Styrene.
Yeah.
These are hazardous monomers. Look, these materials are designed to be tough, to last, which means they don't break down easily or safely.
And that chemical complexity, that's why they fail the blue bin test.
That's a huge part of it.
Yeah.
Both PC and ABS usually get lumped under resin code number 7, the other category.
Ah, the junk drawer.
Pretty much. It's got dozens of different plastics that are chemically incompatible. You can't just melt them all down together and expect to get anything useful. It just doesn't work chemically.
So the system itself, the material recovery facility, the MRF, it just can't handle it.
Well, yeah. The MRFs, they're set up for the big players. PET number 1, HDPE number 2. Think water bottles, milk jugs, these optical sorters, right? Right. But those sorters aren't programmed to even look for number 7 plastics. And here's a kicker for RC hobbyists. A lot of the structural parts, the chassis bits, they're black plastic.
Yeah, loads of them are.
So the sorters use infrared light to identify the plastic type. Black absorbs that light. Poof! The part's basically invisible to the machine.
Wait, so it's chemically tricky and the machine can't see the black parts? Couldn't you just, I don't know, paint a broken chassis white before you bin it?
It's a nice thought, but no. Even if the sorter could see it, think about the contamination.
Ah, right, the dirt, the screws.
Exactly. Metal screws, leftover paint, stickers, grime, all that stuff makes the plastic basically useless for quality recycling. It costs the MRF too much money and hassle to deal with it.
Okay, so the blue bin is really out. That means it falls back on us, the hobbyists. Which brings us to your hierarchy. Tier 1.
Tier 1, life extension. Simple as that. Before you even think about tossing a part, can it be repaired? Can it be reused?
Makes sense. Fix it first.
Absolutely. And there's some pretty cool DIY techniques. Got a broken ABS part. Acetone? You can do what's called solvent welding.
Solvent welding?
Yeah, you use the acetone to slightly dissolve the plastic on the broken edges. Then you press them together, the solvent evaporates, and the plastic fuses back into basically one solid piece. It's a chemical bond.
Wow. Okay. And for the polycarbonate bodies, the shells, they always crack eventually.
Right. For those, you want reinforcement. Clean the crack, then use a strong, flexible glue. Shoe goo is popular, and embed some fiberglass drywall tape right into the goo across the crack. Gives it strength and flexibility.
Does that solvent weld, actually hold up long term? Or is it just a temporary fix?
Oh, no. If you do it right, solvent welding is often almost as strong as the original part. You're forming the chemical structure, not just sticking surfaces together. It's definitely a Tier 1 permanent style fix.
Okay, so repair first. What if it's beyond repair?
Then you move to Tier 2, resale, salvage, or parting out. The RC community is amazing for this. Someone might need that specific gear, even if the housing is cracked. Sell it, trade it, give it away, keep the material in use.
Gotcha. And Tier 3?
Tier 3 is for when repair and resale just aren't options. This is where you might look at specialized, often paid services, like the TerraCycle Zero Waste Box system. It's a mail-in service specifically for hard-to-recycle items. It costs money, but it's an option.
Right. But, okay, if all that fails, Tier 4. This is the one that feels weird, you're saying? Just put it in the regular trash. The general waste.
I know, it feels wrong, doesn't it? But yes, responsibly, as a last resort, it goes in the general waste.
Why is that better than trying to recycle it?
Because trying to recycle it when you know it can't be is called wish cycling. And wish cycling actually harms the recycling system. It costs the MRF time and money to sort out that non-recyclable piece. Worse, it can contaminate a whole bale of actually valuable stuff like cardboard or PET bottles, making that worthless too.
Huh. Okay, so putting it in the general waste protects the integrity of the real recycling stream.
Exactly. It's the responsible, wrong answer, if that makes sense.
It does, actually. So, wrapping this up, what's the main takeaway for you, the listener, right now?
I'd say the most powerful actions are the ones you can take within the hobby community itself. Focus on that Tier 1 and Tier 2. Repairing things, reusing them, selling or trading parts. That's where you make the biggest immediate difference, keeping this tough plastic out of the landfill for longer.
Right. Keep it in the cycle of use.
And looking ahead, maybe a provocative thought here, the ultimate solution might need to shift away from just us hobbyists dealing with the end product.
Towards the manufacturers.
Potentially.
Yeah.
Keep an eye on something called Extended Producer Responsibility, or EPR. It's a policy idea gaining traction. Basically, it makes the companies that make the products financially responsible for managing them at the end of their life.
So, like, the RC companies might have to design for easier disassembly or maybe fund take-back programs.
Precisely. It could force the industry itself to tackle this durability paradox right from the design stage. Something to think about for the future of the hobby.